The next engagement we're going to talk about is Batman Arkham Asylum, which, as I don't know, how many of you know about this game? Have you played it, seen it? Okay, so it's a very, very popular game, probably a contender for Game of the Year for last year. And we started working on this game, back in middle of 2008 is when we started the engagement with the developer. Maybe a little earlier than that. And the idea was, okay, the developers they were very excited about physics, about GPU accelerated physics in particular. They were already using physics because they were using Unreal Engine 3, which physics is the physics engine, Unreal Engine 3. So we wanted to make this showcase title, like all physics. We wanted to have full 3D vision support for this title out of the box. And we want to make sure that we had great graphics performance on all GPUs. And so we sort of engaged with the developer. We did the process that Mark described. This was in Europe, so it was our European guys who did that. They're evangelists we have in Europe too. And so we sat down with the developer, worked with them on like what would make sense, because there's so many opportunities in that game for GPU physics. In fact, it's kind of unfortunate we ran out of time. We could have added even more stuff, frankly. And we literally shipped. We had a whole bunch of our engineers, 3 of the guys from the UK office, 3 engineers from our St. Louis office, 2 artists on site for, I don't know, like months at a time, just rotating in and out. So as it says, so we did the 3D generation, we did the prototypes, and then we started, starting in February, we basically just went all in with all our guys in there. And later on we did a postmortem just to get a sense of how much effort had we put into this. It was pretty substantial. It was about 6 man-years of combined effort. But it was totally worth it, as you saw if you've seen the videos or if you played the game. So there are all kinds of effects in the game, all kinds of ambient effects. The physics is just pervasive as you're walking through even things like cobwebs interact with you. There's like banners of cloth that you can shoot down and it falls. And one of the key features we actually co-developed almost at the same time as the game was being made is destruction using rigid bodies on the GPU, which is something that has kind of never been really implemented in a game before. Where typically you have a rigid body physics, which is everybody believed that it was a CPU only thing. You could never do it as a GPU. But we were determined to prove that wrong. And that was actually turned out to be one of the most stunning aspects of the game, especially towards the end if you played the game in the boss levels. We actually developed all kinds of techniques for smoke while the game was being developed. I'll talk about that a bit more. So here are the physics features, cloth all over the place for all kinds of things. SPH particles. Yes?
What is a rigid body?
Rigid body is basically, if you're modeling the physical world, typically you have things like, my BlackBerry, or this chair, objects like here, that it's rigid in the sense that they're not gonna, the model is basically it won't bend or flex. Right. You can break it potentially, but it won't be deformable. On the other hand, something like this jacket, if it is floating, it's deformable. So it's non-rigid.
When the object collides, it doesn't collapse or bend or change shape.
Right.
As opposed to something like soft bodies, which is an object that has shape. When it collides, the object itself will deform all the way to clothing.
And then you have fluids, which is another aspect where you have fluid behavior. So all of that is in the game. All kinds of effects all over the place for physics. In addition to, so it's not that we just want to work on physics. We wanted to make sure the rendering was there along with it. Otherwise, you kind of have games often in the past with physics have awesome physics and then it kind of don't look that good. And it totally loses the impact of the physics. And so we worked on a bunch of improvements for graphics. One was for shadows, as you saw in the previous talk that Emmett had, where you have this sort of jittered sample type effects that you can add to make this shadow smoother. Otherwise you get these jaggies or shadow acne. So we added that. We improved the performance of a technique called screen space ambient occlusion, which is used to create the notion of shadowing by sort of natural light. Typically, we'll show you some actually pictures of that. And then one thing we did was again Unreal Engine 3 and DX9. So no anti-aliasing in this game. So we added.
You should mention that actually, not only did we do SSAO, we actually implemented a version specifically to help it run on the console too.
That's right.
Right.
Yeah.
So we actually did a performance optimization specifically just to help the console version also.
Right. And so we finally actually decided, just going in the future, we're going to take these techniques for adding anti-aliasing to Unreal Engine 3, and we submitted that to Epic, because it's kind of like, instead of going and working with each developer to fix it individually, if you just give it to Epic, which makes the engine, they can just spread it out to all the developers in the next version of Unreal Engine. Okay. Another thing we added was smoke rendering, which is, there's a whole bunch of smoke effects in Batman, and we developed a whole new algorithm that provides far more better quality and performance. We'll see some screenshots of that in a moment. And we developed a new technique along the way. And this is again one of those, we didn't set out to say, oh, I'm a academic, I'm going to do my research on this field. It was, we need to solve this problem, what can we do? And out of that comes these ideas, these new techniques. And Fourier opacity maps, which we believe is going to get very popular in games going forward. And it was good enough that actually we were able to make a paper out of it and submit it, and it was accepted. And this is actually a pretty prestigious conference on graphics, i3D, Interactive 3D. So here's some example of the Fourier opacity maps. So this is basically, the problem with a lot of smoke effects is they don't shadow. The self-shadowing is non-trivial. And what happens is you can either do a lot of like ray casting, like merge a ray of light and then figure out what the shadowing is. That's really expensive because you have literally thousands of particles in that in a particular smoke effect. And so the question is, well, how can we do this offline type techniques, which are really expensive and done for movies, but make them real time? And can we come up with some approximation of those? And so this is where the FOM or Fourier opacity maps came from. So this shows some nice self-shadowed smoke in Batman. We added 3D vision support, and again, Unreal Engine 3 is a pretty challenging engine for supporting stereo effects. And so we had to literally go and fix most of the engine, actually, to make sure that it worked well with 3D vision. And again, we decided moving forward, let's just submit it to Epic. And by the way, this would mean that any developer can support 3D vision out of the box in Unreal Engine 3, and if there is some other hardware or a competitor, they can, if they have a solution like that at some point in time, they could use all of this too. It's not like you put anything in there that's NVIDIA specific. All right. So, what did we learn from this? First of all, was that the end of my part, or is that?
Oh no, you got a couple more slides.
Oh, okay. That's right. Oh, the AI issue, yes. So we learned that if we put like 6 man-years worth of work, we can actually get something like Batman done. I must say that it was not easy at all. It was very stressful for our guys because they had a very tight deadline. In fact, we were literally working till the last minute before they had the final goal submission to get all of the stuff done, and then test it. And we actually, this is funny, one of my guys had just come back from the UK, and he was the guy who had implemented some of the GPU rigid body destruction, and he was about to go on a vacation, and we literally had to say, okay, no, move your vacation off by 2 days, because we found a bug, and the submission is 2 days from now. So, and we literally had 48 hours to fix this one bug, and so yeah, it was pretty. I don't know. He's still with us, so that's good. He didn't leave. So you guys had Batman as a good example. What we did learn, and we'll talk about that a little later in the next session on physics and Apex, is the key thing is to actually improve the tool chain and workflow so that this doesn't become such a huge effort.
But we want people to be able to do Batman quality experience. with a lot less than 6 man-years of effort each
Right.
game, right? That's hoping livable. I mean, it should be a tenth of that, right? That's what it should be. And the big thing that you're going to learn about in the session after this is we're making a big investment in tools and middleware and infrastructure so that it isn't 6 man-years per game.